Hi, I'm Abena. I'm a fellow student from MIT, and I'm working with Kyle on his exploration of how humans are able to localize sound. I'll start with a definition of what sound localization is. That is the process in which a human hears a sound and analyzes its characteristics to figure out first the direction from which the sound came from, and then the distance that the sound took to travel to reach your ears. So it's basically the method of which we use our sense of hearing to learn more about the 3D world that we live in. So in order to measure the accuracy at which a human can localized sound, we've acquired a 256 speaker array. That is, we have 8 modules where each module has 32 speakers. And we're going to place these modules in a circle around a listener, and we're going to ask the listener to pick out which module the sound is coming from, and then if they can figure out within the module which speaker is bringing out the sound. So we're trying to look for patterns in the behavior and the accuracy among listeners, and also if we can introduce factors that can either increase or decrease the accuracy of sound localization. This speaker array is not just for experimentation, it also provides a creative output, and that is with the use of wave field synthesis. So wave field synthesis is a method where we're able to create these virtual sound objects around an area using the array of speakers. So each speaker is going to emit a small laser of sound, and when these sound waves overlap, they can either interfere constructively to bring out a nice noise, or they can interfere destructively and cancel each other out. So with a combination of time delays and filters of these sound waves from all the speakers, we're able to make it seem like a sound is originating from a location other to where the speakers are actually located. So with a combination of a bunch of different placed sound objects, you're able to create virtual audio realities. So the wave runs can mimic a desired environment and get you this immersive sound experience. And these objects don't need to be stagnant. You can add movement to the objects to add dynamics and life into the environment that you're creating. So I would like to invite you to my demo in the next room, where you can get a firsthand experience of what this sound reality would look like. So overall, audio is an essential layer that we use to perceive the world around us, and wave field synthesis is a way that we can approximate an audio reality where our brain is able to fill up the gaps, making it believable even though it might not be completely physically accurate. So along with the studies of the ability of a human to localize sound, we can look at which parts are essential to make the reality more believable, and which parts are lost or not processed by our brains. We're basically world building when it comes to making these audio realities, and by examining how humans are able to behave in these generated environments, we can increase our understanding of how humans are able to use audio to understand our actual environment. That's the conclusion of my presentation. I'll now pass it on to Tim.